Good morning, everyone. A very good morning. Shall we begin the session? Yes, today's topic is the aggregate functions. In the last class, we have finished with the various formulas, various operations, various operators that is used in the SQLs. Now, continue with the same. Now, next part is what are the various functions, or aggregate function that is used in the SQL. So aggregator functions are those functions that takes a collection, a set or multi-set of values as input and returns a single value. That value may be a single value, that value may be a multi-value, that means more than one output. And the SQL offers 5 built-in aggregate functions. What are the 5 aggregate? One is AVG average, then MIN min, then MAX maximum function, then sum, that is a total, then count, that is count function. So the input to the sum and the average must be a collection of the numbers, but the other operators can operate on a collection of the non-numeric data types such as the string as well. That means we can also use the strings, we can also use the numbers. First is basic aggregation. So consider the query, find the average salary of the instructors in the computer science department. We write this query as follows. Select the AVG salary from instructor where the department name equals to computer science. Now, salary average will be finding out. That means addition of all the salaries divided by whatever the number. For example, if there are 5 floors, so addition of each and every department salary that is divided by the 5. So select AVG salary from instructor where department name equals to computer science. The result of this query is in a relation with a single attribute containing a single tuple, that is single row, with a numeric value corresponding to the average salary of the instructors in the computer science department. And database system may give a name to the result relation attribute that is generated by the aggregation. However, we can also give a meaningful name to the attribute by using the as clause also, that means changing the name. This is the select AVG salary as AVG salary. Now the new name for the field is AVG underscore salary from instructor where the department name equals to computer science. And in the instructor relation of figure this one, the salaries in the computer science department are 75, 65,000, 92,000. So average is 232,000 divided by 3. So this will find the average will be 77333, then 0.33. And the retaining duplicates is important in computing an salary or average. Suppose the computer science department is using the salary that is paired with the 4th instructor whose salary happens to be around 75,000, and if the duplicates were eliminated, we must obtain the wrong answer, that is 232,000 divided by 4, that is 58,000, rather than the correct answer is 767.50. That means it is also chasing out, it is also taking out the duplicate values. Alright, let's begin with the session. Now to eliminate the duplicate results, we have to use a distinct keyword. So this is select count. So we are using the functions as well as the distinct keyword. So select count distinct ID. That means the ID will be finding out with the distinct values from teachers. What are the various teachers? Yes, from teachers where the semester equals to spring and the year equal to 2010. That means semester is given as a spring as well as that means and. There is no that if one of the condition is satisfied, then the output will be displayed. No. Semester will be string and the year will be 2010. And because of the keyword distinct proceeding ID, even if an instructor is using or teaches more than the one course, she is counting or she is counted only once in the result, because we are using both the values at the same time, spring and the 2010. Then we use aggregate function count frequently to count the number of tuples in a relation, and the notation for this function in SQL is count as string. That means count each and every function. So to find the number of tuples in the course relation, we write select count as string from the course SQL does not allow the use of the distinct with the count. It is also legal to use the distinct with the max and the min, even though the result does not change. We can use the keyword all in the place of the distinct to specify the duplicate retention, but since all is the default, so there's no need to do this because by default it is available with each and every tuple. The next part is the aggregation with the grouping. Now we are aggregating the functions with the use of the group keyword. There are circumstances, there are some scenarios where we would like to apply the aggregate function not only to a single set, but we can apply that to the multiple set or the set of the cells or tuples. So we specify this wish in a SQL under the group by clause, and the attribute or the attributes given in the group by clause are used to form the group. Tuples with the same value on all the attribute in the group by clause are placed in one group. And as an example, consider the query, find the aggregate salary in each department. Not the aggregate salary, so sorry, find the average salary for each department. So select department name AVG salary as AVG underscore salary. That means the field name is given as the AVG underscore salary, but it is finding out the function or finding out with the function AVG from instructor group by department name. And this also shows the tuples in the instructor relation that is grouped by the department name attribute, which is the first step in computing the query result. The specified aggregate is computed for each and every group, and the result of the query is shown over here, that is figure 3.15. This is the department name, there is the average salary. For the biology, there are 3 salaries, so we have to count addition of each and every salary, that is divided by the 2. Sorry, that is divided by the 3. In the same way computer science, in the same way electrical engineering, in the same way finance, history, music, and the physics. So the result relation for the query, that is find the average salary in each department. In this case, we are using the group by clause that has been omitted. So the entire relation is treated as a single group. As another example of the aggregation on the group of the tuples, consider the query, find the number of instructors in each department who teaches a course in the spring 2010 semester. In that case also, information about which instructors teaches which course in which semester is also available in the teachers relation. However, this information has to be joined with the information from the instructor relation to get the department name of each instructor. Therefore, we write this query as follows. Select department name, count distinct ID as instructor count from instructor natural join teaches, where the semester equals to spring and the year equal to 2010. That is grouped by department name. And whenever we are applying the SQL query using the grouping, it is very important to ensure that the only attributes that appear in the select statement without being aggregated are those that are present in the group by clause. In other words, any attribute that is not present in the group by clause must appear only inside the aggregate function, only if it appears in the select clause. Otherwise, the query is treated as enormous. For example, the following query is enormous since ID does not appear in the group by clause and yet it appears in the select clause without being aggregated. There is a department name, there is the instructor count, then computer science 3, finance 1, history 1, music 1. So the result relation for the query, find the number of instructors in each department who teaches a course in the spring 2010 semester. So we have to find out, or we have taken out the department name, ID, AVG salary from the instructor group by the department name. Each instructor in a particular group is defined by the department name that can have a different IDs since only one tuple is output for each group. And there is no unique way of choosing which ID value is to be output. As a result, such cases will be disallowed by the SQL. Next is having clause. At times, it is also useful to state a condition that applies to a group rather than to the tuples. For example, we might be interested only those departments. Listen carefully. We might be interested for only those departments where the average salary is more than 42,000. Now we are finding out the average salary as well as taking out the condition that the average salary is more than 42,000. Though this condition does not apply to a single tuple, rather it applies to each group constructed by the group by clause. So to express such a query, we are using the having clause of SQL that applies predicate in the having clause after groups have been formed. So aggregate functions may be used. So we express this query in SQL as follows. Select department name, AVG salary as average salary from instructor group by department name. Having the average salary is greater than 42,000. And as was the case for the select clause, any attribute that is present in the having clause without being aggregated must appear in the group by clause. Otherwise, the query is treated as enormous. The meaning of the query containing aggregation, group by, or having clauses is defined by the following sequence of the operations. And as was the case for the query without aggregation, the from clause is first evaluated to get a relation. The department name, AVG salary, physics 91,000, electric engineering 80,000, finance 85,000, computer science 77333, biology 72,000, history 61,000. The result relation for the query, find the average salary of the instructors in those departments where the average salary is more than 42,000. And if a where clause is present, the predicate in the where clause is applied on the relation or the result relation of the from clause. And tuples satisfying the where predicate are then placed into the groups by the group by clause if it is present. And if the group by clause is absent, the entire set of the groups tuples satisfying the where predicate is treated as being in one group. So having clause, if it is present, is applied to each and every group, and the groups that do not satisfy the having clause predicate are removed. Then select clause also uses the remaining tuples or groups to generate the tuples of the result of the query. Then applying the aggregate function to get a single result tuple for each group. Then select course ID, semester, year, section ID, average, total credit from takes natural join student where year equals to 2009. Yeah, single equals to is also applicable. We can either use single equals to or double equals to. That is group by the course ID, semester, year, section ID, and count ID is greater than equals to. And next is aggregation with the null and the boolean values. Now the next part is the aggregation with the null values and the boolean values. So null values, that means blank spaces. When they exist, complicate the processing of the aggregate operators. For example, assume that some tuples in the instructor relation have a null values for the salaries. Consider the following query to total all the salary amounts. So select sum salary from the instructors. So value to be summed in the preceding query that includes the null values as well. Null values is treated as a zero. So rather than say that the overall sum is itself the null, the SQL standard use the sum operation that ignores the null values, either ignores or either use the zero value, that is the one and the same thing. So in general, aggregate function treats the null according to the following rules. All the aggregate functions except count, asterisk, ignore the null values in their input collection. And as a result of the null values being ignored, the collection of the values may be empty, and the count of an empty is defined to be the zero. As I said, that is defined to be a zero, that is said to be at zero, and all the other aggregate operations returns a value of the null when applied on a empty collection. And the effect of the null values on some of the more complicated SQL construct can be subtle, can be used. And the Boolean data type that can take the values or that can take values true, false, and unknown was introduced in the SQL. And the aggregate function sum and every, that means exactly what you would intuitively expect and can be applied on a collection of the Boolean values. The next topic is a nested subquery, that is a select from clause, select from where expression that is nested within the other query also, and the common use of the subquery that is used or that can perform the test for the set membership, that make the set operations, set comparisons, and determines set cardinality. So there are two parts, one is a projection, one is a selection. by nesting the subqueries in the where clause also. The next one is the set membership. So the SQL also allows the testing tuples for a membership in a relation, and that is used in the in-connective test for the set membership, where the set is a collection of the value produced by a select clause. Select course ID from section where semester equal to spring and the year equal to 2010. We then need to find out those courses that were taught in the fall 2009 and that appears in the set of the courses obtained in the subquery. So we do so by nesting the subquery in the where clause of the outer query. So the resulting query is select distinct course ID from section where semester equals to fall and the year equal to 2009, and course ID in select course ID from section where semester equals to spring and year equal to 2010. This example shows that it is also possible to write the same query in several ways in SQL, and this flexibility is beneficial since it allows a user to think about the query in the way that seems more natural, more healthier. We shall use that there is a substantial amount of redundancy in the SQL also. So we are using not in construct in a way similar to the in construct. So to find out the courses that taught in the fall 2010 semester but not in the spring 2010, so we use select distinct course ID from section where semester equals to fall and year equal to 2009. So select distinct course ID from section where the semester equals to fall and the year equal to 2009, and course ID not in select course ID from section where semester equal to spring and year equal to 2010. That means we are using both considering the both values, that is the fall and the 2009, and course ID not in the select course ID from section where semester equals to spring and year equal to 2009. That means we are using both in and not in operator, and that can be used on the enumerated sets. And the following query selects the name of the instructors whose name are neither the Mozart or Einstein. So select distinct name from instructor where name not in Mozart or Einstein. And in the preceding examples, we tested the membership in one attribute relation. That is also possible to test for the membership in an arbitrary relation in the SQL. For example, we can write the query, find the number of the distinct students who have taken the courses or course sections taught by the instructor with the ID 110011. So we write the query as a select count distinct ID from text with the course ID, section ID, semester year in select course ID, section ID, semester year from teachers where the teachers.id equals to 10101. This is not correct, this is 11001. So next part that is available, that is a set comparison. So as an example of the ability of the nested subquery to compare the sets, we are using the query find the names of all the instructors whose salary is greater than at least one instructor in the biology department. So we wrote the query, select distinct t.name. So select distinct t.name from instructor as t and instructor as s, where t.salary is greater than s.salary and the s.department name equals to biology. And this is a subquery, select the salary from instructor where department name equals to biology. We are using the greater than, we are using the less than, each and everything that we are using. Now next is test for the empty relations. We are also testing for the empty relation. This is select course ID from section as S where semester equals to fall and year equal to 2009, and exist select star or asterisk from sections ST where semester equals to spring and the year equal to 2010, and s.course ID equals to t.course ID. That is outer query, that is a subquery that has a correlation name from an outer query that is also known as the correlated subqueries. And in queries that contain subqueries, a scoping rule applies for the correlation name, and in a subquery according to that rule, it is also legal to use only correlation names defined in the subquery itself or in any query that contains a subquery. There is a not exist construct, not exist simulate that contains except So select distinct SID SName from student as S where not exists. Select course ID from course where department name equals to biology, except select T.course ID from takes as T where S.id equals to T.id. The next is test for the absence of the duplicate tuples. So select T.course ID from the course as T where unique. Select R.course ID from section as R where T.course ID equals to R.course ID and R.year equals to 2009. Next is comparison of the queries as a select T.course ID from the course as T where 1 is less than select count R.course ID from section as R where T.course ID equals to R.course ID. So we can use or we can test for the duplicate record, duplicate tuples in a subquery by using the not unique construct. And formally, the unique test for a relation is defined to fail if and only if the relation contains two tuples, that is a T1 and the T2. So that T1 equals to T2, and since the test T1 equals to T2 fails if any of the fields of T1 and the T2 is null or are null. Then subqueries in the from clause. Select department name every salary from select department name every salary at every salary from instructor group by department name where every salary is greater than 42,000. This is the same, this is the same. Then with clause that is not in your syllabus. Scalar subqueries dot also. So syllabus. Next is modification of the database that we already done. That is a delete command. It is a DML command that is expressed in much the same way as a query. We can delete only those or only whole tuples. We cannot delete values on this. So we can delete the whole tuple or the full tuple, but we cannot delete the values on any particular attribute. So this will be used. That is select from R. Sorry, delete from R where P represents a predicate and R represents a relation. And the delete statement finds first find all the tuples T in R for which PT is true and then deletes them from R. And the where clause can be omitted, in which case all the tuples in the R are deleted. And note that the delete command operates on only one relation. If we want to delete tuples from several relations, we must use delete command for each and every relation. And the predicate in the where clause may be a complex as a select command in the where clause. Now these are the example of the SQL delete request. Delete all the tuples in the instructor relation pertaining to the instructor in the finance department. Now this is delete. This is delete from instructor where department name equals to finance. So delete all instructors with a salary between 13,000 and 15,000. This is delete from instructor where salary between 30,000 and 15,000. Delete all the tuples or delete from instructor where department name and select department name from department where building equals to vets. On a delete request, first find all the departments located in the vetsum and then deletes all the instructor tuples pertaining to those departments. And note that although we may delete tuples from only one relation at a time, we may also reference any number of relation in a select from clause nested in a where clause of a delete. That may contain a nested select that reference the relation from which the tuples are to be deleted. The next one is the insertion. So insert the data into the relation. We either specify a tuple to be inserted or write a query whose result is the set of the tuple to be inserted. So therefore we are in the insert statement to find out the request to insert one tuple. So insert into course values CS1 CS437 database system computer science 4. Then update. This is also a DML command. Whatever the modification we have done in the database, that is a DML command. So in certain situations, we have also wish to change the value in the tuple without changing all the values. So we use that update command. Yeah, in this update means changes in the record. So sorry. Suppose, for example, the annual salary increases are being made and the salary of all instructor are to be increased by the 5%, that is 0.5. So update instructor set salary equal to salary into 1.05. Then at last there is a summary. So SQL is the more or the most influential commercially relational query language that has two parts. One is a DML, one is a DDL. DML that provides a command for defining the relation schemas, deleting relation and modifying the relation schemas. DML includes a query language, commands to insert the tuples, delete tuples from and modifying the tuples. Then data definition language that is used to create the relations with the specified schemas. In addition to this, specifying the names, types of the relations attributes. SQL also defines a specification of the integrity constraint, such as a primary key constraint, foreign key constraint. And SQL also includes a variety of the languages construct for the queries on the database. This includes the select from and where clause. And SQL also supports basic set operations on the relation that may be a union, that may be an intersect, that may be an except, which correspond to the mathematical set theory. Operations like union, intersection, and the except. And SQL also supports nested subquerying in the where and the from clauses of an outer query that also support the scalar subqueries. Whenever an expression returning the true, whenever an expression returning a value is permitted. And SQL also provides a constraint or constructs for updating, inserting, and deleting the information. Next is the review terms. Next, practice exercises. These are the various practice exercises. Then bibliographic notes. Chapter number 4 is intermediate SQL that I'm going to start within the next class because today we have finished too much. So please read out this one, and if there's any doubts you can clarify the doubts right now also because 10 minutes are left for the class. So any doubts regarding the assignment, anything that you want to ask. But the next chapter I'm going to start within the next class, that is in the tomorrow's class. Alright.